Hi guys, we're on lesson 20 of friendly chemistry, putting compounds into reactions. This is a fairly long chapter as far as words go because they compare chemical compound reactions to relationship. But if you follow along with me starting on page S184, I'll highlight the important things for you to get out of it, at least in chemistry terms, terminology and such. I'll see if I can't get it clear so you can see here. First of all, the first keyword to know is what a chemical reaction is. A chemical reaction is an interaction between two or more chemicals, whether they're single elements or compounds. Participants in a chemical reaction brings to your second term. They are known as reactants. The things that interact with each other or react with each other are reactants. Now the results of the reaction are known as the products. In order to say that a chemical reaction has taken place, there must be evidence of a chemical change in the reactants. And there are generally three types of these: a change in the chemical properties, a change in the solubility or how a substance dissolves with another substance, or a change in color. An example of a chemical property change would be sodium plus chloride, giving you table salt. If you remember, sodium is a very highly reactant element that is very explosive. Chloride is a poison. You put them together and you end up with table salt, very non-reactive and necessary for our diet. An evidence of color change in a chemical reaction, they have several good examples here, but sodium hypochlorite, which is known as chlorine bleach. If you've ever put that in the wash with your blue jeans with white spots, you know that that causes a color change. And a good example of solubility, we've moved on to page S186, is when you make cheese. When vinegar is added to your milk, your warmed milk, your milk proteins clump together at the top. They're no longer dispersed in the milk, or they're no longer soluble. They actually begin to form a precipitate because they're insoluble now. And any insoluble product of a chemical reaction is called a precipitate. And those curds, eventually they culture into cheese. Now, also, to get a chemical reaction, sometimes we have to put energy into creating a reaction. Sometimes it's as easy as shaking or stirring, putting in heat, or putting in electricity. For example, if you bake a cake, we have to beat the mixture so that the carbon dioxide bubbles start from the baking powder, and that way the cake will rise. So that's beating it. Other type of reactions you have to put heat in, or things like that. Those type of reactions, though, that you have to put the energy in order for the reaction to occur, are called endothermic. The prefix endo means putting in, and thermic means either heat or energy. On the other hand, some reactions produce and release energy as the reaction continues in the form of heat, light, or sound. If your reaction produces heat, light, or sound, it's called an exothermic reaction. Exo meaning leaving or exiting, thermic again meaning heat or energy. An example of both is if you strike a match. You strike the match, it starts out as an endothermic reaction, and then as it continues to burn, the remaining actions are exothermic. They give you several examples down on the end of page 187 up to 188, and they want you to guess whether they're exothermic or endothermic, and they give you the answers in there. Those are good practice. Then, once they've given you the definitions, they go into what you're going to practice in this, and that's writing a chemical equation. A written description of a chemical reaction, whether it's in words or symbols, is called a chemical equation. And a chemical equation written in words starts here on 188, S188. Hydrogen and oxygen react to produce water. And you can write that in chemicals. If you write it, in symbols. If you write it in symbols, you put your hydrogen plus sign, your oxygen, and then you have an arrow for the equals or makes, and then you have your H2O. So you put your reactants on the left side of the equation and your products on the right side. Now if it's a two-way equation where it can go both ways, like in the hydrogen and iodine, excuse me, it can go both ways, and you have two arrows, so it can go back and forth for a reversible. You can also add what state of matter your reactants are in while you're during the reaction, whether solid, liquid, or gas, being an S, an AQ for aqueous or aqua, or L for liquid, or G for gas. Like in your gaseous nitrous oxide example here, you see how they list there's a gas and a liquid and a liquid and a gas. If there are conditions required for the reaction to take place, those can also be added. Like in the ammonium nitrate reaction, it has to be at 200 degrees Celsius. So they put the 200 degrees Celsius over the action. These are important because they're going to have you practice writing some of these. Sometimes a catalyst is necessary. I'm now on page S190. If a catalyst is a substance that when you add it to the reaction, it increases the speed, but the catalyst itself is not changed in the reaction. If you need a catalyst, that can be written in on the equation. Right here, you have the heat plus a catalyst is going to help this equation continue. And then the last thing that they mention to you, which is important for your practice, is that some gases at room temperature like to exist as diatomic gases or two atom pairs. And they list them in here for you. Oxygen, hydrogen, chlorine, bromine, nitrogen, and iodine, although that's not a gas at room temperature. When you are writing your chemical equations, starting on S191, remember if a byproduct happens to be one of those diatomic gases, you're going to want to add your 2 there, just like in number 1 that's done for you. The happy thing with lesson 20 is there's not a lot of math for you. An unhappy thing for you is there's a little more reading, and then there's some practice with chemical equations and chemical reactions in here. Good luck with that, and have a great week, and I'll see you on Monday for another experiment.